Alright, we're going to go over section 1.4, which is factoring polynomials. We went through a little bit of factoring review with the last section, although that wasn't the objective of the last section. This time we're going to proceed on to factoring polynomials. These first four examples were factoring out the greatest common factor. And that's normally the first thing you want to do when you factor polynomials, is see if there is a greatest common factor. Factor that out and then go on and factor it further if you can. So you have to discover the greatest common factor. Sometimes it's obvious, sometimes maybe it's not as obvious. But in number 1 here, a x squared is a times x times x. And then we have plus 3ax cubed, so that's 3 times a times x times x times x, 3 x's. Alright, if we look at that, what do they have in common? Well, they both have an a, and they both have an x and another x here, and they both have an x and an x. Well, then that's all they share. That's the common factor. That's what they have in common. So we can pull out or divide by ax squared. That's the common factor. And then if we divide each of these expressions by that, well, what do we have left? If we have ax squared divided by ax squared, then we have 1 plus, and what do we have left here when we divide by ax squared? We have 3x left. So if you need to, you can go through and separate these things out, just like when I showed you multiplying bases with exponents. You can separate them all out, underline the pieces that they have in common, and then write down the factors with the greatest common factor in front. Most of the time you're not going to go to that much trouble, but it doesn't hurt to do that. We'll do that again with number 2. This first term is 2 times m times y. And the second term is 8 times m squared. It'd be m times y. So, well, we have a 2 here, but 8, instead of 8 is 2 times 2 times 2. So we have 1, 2, and a 2 here. We have 1 m in common, and we have a y in common. So our greatest common factor is 2my. And then all of this we've used, so there's 1, 2my times 1 will give us that term, minus what we didn't use here is 4m. That's what would be left if we divided it by that greatest common factor to find out what was left over. So we have 4m. So our answer is the 2my in front. The greatest common factor always goes in front, and then the rest, the remainder, it will be the factor that follows. So let's look, see if we can do this. We have 3 terms. Well, all of these are divisible by 7, and this has a 7, so we know our greatest common factor is going to have a 7 in it. Do they all have an a? No. This middle term doesn't have an a. Do they all have a b? Yes, they all have at least one b, and this one has 1. So 7b is our greatest common factor. Now, divide this by 7b. This is how you're going to get what's left. What's left there is an a. Divide this by 7b, our greatest common factor. So what's left there is 2. And divide this by 7b. And what's left is plus 3a squared. Okay. So that is the way you could do it without separating them all out and finding the greatest common factor that way. Looking at number 4. Well, this has x squared. This has x cubed. There's no number here, so we can't pull out any number. Right? But we can pull out an x squared because they both have at least 2 x's. This has 1y, this has 3. So they both have at least 1. Okay? Now divide this by x squared y by your greatest common factor, and you find that that is 1, minus, divide this by x squared y, and you're left with 6x y squared. And that's your answer. So that's factoring out the greatest common factor. Again, this should be review, but if it's not, you need to really work on the practice and get this straight in your mind. Alright, now there's some special patterns in factoring, and those are the ones I talked about yesterday, or maybe even earlier today, but in the last lesson. This is called perfect square trinomials. And what you notice, first of all, that there are 3 terms in your original polynomial. Here's 1, here's 2, and here's 3. The terms are separated by plus signs or minus signs. Alright, this will factor as a plus b squared. It's a perfect square trinomial. Remember those that we did in 1-3 that I showed you that? Okay, here's the pattern. And my writing with emoji is not very good, so if you can't read my writing, listen to my words. The first and last terms are squares, are perfect squares. That means you can take the square root without any kind of decimal number or anything. It's a perfect square. 25, 36. You can take the square roots of those numbers. Or x squared. Okay, the first and last terms are perfect squares, and the middle term, this is the tricky part that it's a little tricky to recognize. The middle term is 2 times or double okay, it's 2 times the first term times the last term. Okay, the square root, I should say. The square root of the first term okay, times the square root of the last term. Okay. Now, the difference of 2 perfect squares factors, and if you notice here, let's start. First thing you notice, so I didn't mean to erase that, so let me go back and undo. Okay. This has 2 terms only. So if there's 2 terms, and the next thing that you have to notice is the minus sign. Okay, it's got a minus sign. If it has a plus sign in 2 terms, it's not a difference of 2 squares. It's a you can't factor it. So if it's 2 terms with a minus sign, that's the first thing you have to look for. Then it could be a difference of 2 perfect squares. And if it is, it's going to factor as a plus b times a minus b. A, b, and b being the square root of the terms that you see in the binomial. Now, so it's not just the minus sign you have to look for. You have to look for the fact that both terms are perfect squares. Okay. Okay, very good. Now the last one, trinomials on this page anyway, trinomials with a lead coefficient of 1. So trinomial means, again, you have 3 terms. Okay, an example, a squared plus 5a plus 6. This would factor, and there's a lot of things to look for in these. First, the first term goes in as the square root of each of that term, a and a. Then you look at factors that will multiply to be the third term, since the first term is 1, the coefficient there is 1. Multiply to be the third term, so it's going to multiply to be 6 and add to be 5. So that'll be a plus 2 times a plus 3. Now, first thing you look for, that the lead coefficient is 1. That means there's just a squared or x squared or b squared or whatever variable that they have, but the lead coefficient is 1. Okay. Then the thing you need to look for is look at the second sign. Look at the second sign. If the second sign is positive, both terms are positive. Or both are negative. But in other words, if the second sign is positive, the signs are the same. If the second sign is negative, then you have one of your factors is positive, and one is negative. Now I'm running out of space here, so I'm going to have to go up on the side. If you take notes at school, you can continue on. There's room at the bottom. Then you need two numbers. After you've done that, I'll draw a line here to see where this goes with this. Okay, so after this is your first step, this is your second step, then your third step. Find two numbers that should be a D. Find two numbers that multiply to get the third term. In this case is 6. And then they add or subtract if it's a case where the second sign is negative, they'll subtract. They add or subtract to the middle term. And I apologize for my writing. My pen is not writing well, and my hand is going numb. Okay, so you find your lead coefficient is 1, which we checked right here, right there. We checked the second sign right here is positive, so that meant both terms are going to be positive. And then we multiply to get the 6, which is 2 times 3, and those add together, 2 plus 3, to be 5. And those then will be our two factors. Alright, let's move on to the next page. Alright, we have a lot of factoring completely's examples here, and I'm going to try to go through this pretty quickly. Alright, on this one, let's first look for a greatest common factor, which is going to be 3xy, which is going to leave you with 2 minus xy. And we look at this parentheses, and we can't factor that anymore, so we stop there. Looking at number 2, we have the number that's the greatest common factor will be 7. They all have an x. They do not all have a y. See, this last term is missing a y. So we stop there, divide by 7x. So we are left with y, this is our first term, minus 21 divided by 7 is 3. We divide by the x, so we have left xy squared. And plus 14 divided by 7 is 2, x divided by x, that means x will cancel. So that's what goes in the parentheses after we divide through by our greatest common factor. Looking at number 3, First, let's check, is this a perfect square polynomial? The square root of the first term is x. The square root of the second term is 3, so those meet the criteria of perfect squares so far, because we can take the square root of the two end terms. Now we multiply these together, 3 times x, that's the square root of the first term and the last term, double it, and we get 6x, so that means they're both positive signs, so this will factor as x plus 3 squared. Okay. Always factor out your GCF first if there is one. There's not a greatest common factor here. So let's look. We've got a plus sign second, so that means both terms are going to be negative. We've got the square root of x squared is x. The square root of 25y squared is 25y. If we multiply these two terms, excuse me, 5. What am I thinking? Okay, 5y. Or if we multiply these together, we get 10xy. Double it. If we multiply these, we get 5xy. Double it, you get 10xy. They're going to be subtracted because both signs are the same when your second sign here is positive. So this will factor as x minus 5y squared. Here we have two terms. We can take the square root of both terms. We have x and we have 6. There is a minus sign between them. We had to check that. So that means this will factor as a difference of squares, x plus 6 times x minus 6. Okay. Now these are easy to see for most of you. For some reason number 6 might not be. But look, can we take the square root of each of these terms? Yes. We have 2x and we have 9. We have a minus sign between, so that means that'll factor as 2x plus 9 and 2x minus 9. And it doesn't matter whether you put the 2x minus 9 first or the 2x plus 9 first, because it doesn't matter the order you multiply in. Alright, look at this last term. There's no greatest common factor to factor out. That's one thing you always do first, is the greatest common factor. This is not a perfect square because we can't take the square root of 12. So let's look. Let's look at what we know. Let's use our method. We're going to know that the coefficient is 1, so the first term is going to be x in each of them. The second sign is a minus, so that means we're going to have one factor that's positive and one that's negative. Now we multiply, we need two numbers that will multiply to be negative 12 and add to be 4. Factors that will multiply to be 12. Well, positive 6 and negative 2 will multiply to be 12 and they'll add to be 4. So that means those are the numbers that go in here. X plus 6, x minus 2. Alright. Look at your second, or number 8 here. Again, a coefficient of 1. We can't take the square root of 8, so we're going to look to see if we can factor it. First term is going to be x. The second sign is positive. The first sign is negative, so that means both these factors are minus. Alright, we need things that will multiply to be 8 and add to be negative 6. Okay, well, and we know that they have to be negative, so negative 4 times negative 2 will be positive 8. Negative 4 plus negative 2 is negative 6. So my answers, my factors are x minus 4 times x minus 2. And if you want to show this in your notes where it's more clear what I'm doing, okay, and this is negative 4 plus negative 2. And same, you can do that same on number 7 example. Alright, look at 9 and 10. This is an example where you think, okay, I can't take the square root. I can take the square root of 16 and I can take the square root of 100. So we can do that, but there's also a greatest common factor. So let's first factor out our greatest common factor, which is 4. And so we have 4. Remember, do the GCF first. I'll write that up here. GCF first. Big exclamation point. So that'll leave us with 4x squared minus 25. Now this we can factor even more because we can take the square root of 4x squared and the square root of 25, but we still have to write the greatest common factor out here. And then we have 2x and 5, and so that factors as a difference of squares, 2x plus 5 and 2x minus 5. And now we're down to linear factors, which means the highest power of x is x to the first. And once you're down to linear factors, you're not going to be able to factor anymore. As long as you still have a quadratic factor or a higher power factor like we did right here with x squared, it's possible you could factor further. Now, so not always, but in this case, yes, you could go on and factor more. So don't stop here. Looking at this one, we have a greatest common factor of 5. So we factor out a 5, and that leaves us with x squared minus 4. Two terms, and this is a x squared, so we may not be done. Can we factor x squared minus 4? Yes, we can. That's a difference of squares. And that factors as x plus 2 times x minus 2. And so that, be sure that you go complete your factorization and don't stop too soon.